Number 12. A wire 10 meters long is cut into two pieces. One piece will be shaped as an equilateral triangle and the other piece will be shaped as a circle. Part A. Express the total area A enclosed by pieces of wire as a function of the length x of a side of an equilateral triangle. So we're doing 12A. And you know the area of a triangle is the square root of 3 over 4 times side squared. Then you know that the side, since it was stated, is x, so the square root of 3 over 4 x squared. Okay. Then you know that the wire length is 10 minus 3x. The 3 from the sides and the 10 from the meters. So the perimeter would be P equals 10 minus 3x. And you know the perimeter of a circle, which is 2 pi r. So it would be 2 pi r equals 10 minus 3x. Then you want to isolate the r, so r would equal 10 minus 3x over 2 pi.
This is a continuation of part 12a. Thank you to Kelsey for finding the radius is equal to 10 minus 3x over 2 pi. Now we're going to find the total area encompassed by the equilateral triangle and the circle. First, we need to find the area of a circle, which is equal to pi times the radius squared. We're going to plug in the equation for the radius into r. A equals pi multiplied by 10 minus 3x over 2 pi. We're going to square what's in the parentheses. First, we're going to do that. So area is equal to pi times 10 minus 3x squared over 4 pi squared. If you notice, we can cancel out one of the pi's down here with the pi multiplying the whole equation. So area of the circle will be equal to 10 minus 3x squared. Ooh, I wrote that wrong. 3x squared over 4 pi. And this is our area of the circle. Next, we're going to find the area of the equilateral triangle. The formula is the square root of 3 over 4 multiplied by the side length of the triangle, which we'll say is x in this case, squared. So these are our formulas for the triangle and the circle. We're going to add these together to find the total area. So our answer will be A equals 10 minus 3x squared over 4 pi plus the square root of 3 over 4 multiplied by x squared. And this will be our final answer for part A.
Part B, we are now going to be finding the domain. So our domain has two restrictions, the first being that 3x must be greater than or equal to 0. 3x is the length of the rope used to create the triangle, so it cannot be a negative number. Hence why we set 3x as greater than or equal to 0, meaning that it cannot be a negative number. Now we are going to try and isolate x, meaning that we have to divide by 3 on both sides, leaving us with x is greater than or equal to 0. Dealing with our second domain restriction, we have to set 10 minus 3x as greater than or equal to 0. 10 minus 3x is the length of the rope used to create the circle, which also cannot be 0. First, we are going to divide by 3 to every number and on both sides of the equation. This leaves us with 10 over 3 minus x is greater than or equal to 0. Lastly, we're going to have to add x to both sides. This leaves us with 10 over 3 is greater than or equal to x. Now we have gathered the information that x has to be less than or equal to 10, but greater than or equal to 0. This means that x can be any real number in between 0 and 10 over 3, and we include brackets because the number can also be 0 and it can also be 10 over 3.
Okay, I'm doing problem 12C, which states graph a equals a of x, and for what value of x is a smallest. So as seen before, we already know that the total area is 10 minus 3x squared over 4 pi plus the square root of 3 over 4 x squared, and the domain is all values from 0 until 10 over 3. And graphing this, I graphed it on Desmos. It said that the smallest value of a is when x equals about, it's 2.07, so about right here. And the value of y is 2.99, so almost 3. So 1, 2, 3, that's about right there. And 0 is 1, 2, 3, 4, 5, 6, 7. Okay, so about right there. And that's what the graph looks like if you include the domain.